So section 11.3, we were discussing hyperbolas, and we're going to do a few more examples of that kind of stuff. This one's asking you to reverse engineer a hyperbola, figure out its equation. Now, I guess the first thing you got to do is decide which form of the equation it's going to be. Is it going to be the first one or the second one? Which one do you think? Which one looks correct for this kind of information, where you have a foci here and two parabola that face left and or hyperbola that face left and right? Yeah, no. Yeah, there you go. That's better. 1. Because if the x squared is positive, it's going to open around the x-axis, or at least parallel to the x-axis. All right, so thank you, Henry. Now, let's just take a look at this little distance right there. And that little distance right there, that's telling you one of these parameters. That's going to be a equals 3. So, nice. That's half of our work right there, figuring out what a is. But there's another number we have to figure out, and that's our b. Unfortunately, we can't figure out b directly. B has to be figured out indirectly, and it's going to come from this formula. C squared equals a squared plus b squared. That tells you the distance away from the center that the foci lie. So, all right. Let's see what we know here. Well, this distance here, that's our C. So C equals 5. Now that actually makes this a Pythagorean triple. That is, these integers will work out pretty nice. I'll get 5 squared equals 3 squared plus b squared. Or 25 equals 9 plus b squared. 16 equals b squared, so 4 equals b. Yeah, there's a plus and minus 4, but I'm just going to go with the positive 4 here for this. So that gives me my equation. So I get x squared over 3 squared minus y squared over 4 squared equals 1. Yay! Now let's take a look at that on Desmos a little bit, just to reinforce some of the things that I expect to view on an exam. So it would be over here. Here was our given. And then once we determined our equation, we can draw that box and its diagonals. So that would look like this. And this is kind of the things I expect from you when you graph a hyperbola for me. I expect this rectangle here and the asymptotes that go through the diagonals of the rectangle. In this case, it looks more like a square, but that's okay. And that's pretty much it. We've got the foci here. We've got the vertices. It opens left and right. Looking pretty good there. So, how's that first one going? Doing okay? Let's keep rolling and try the second one. So, problem B. And I'll shut this off and we'll take a nice visual look at the given information. Now actually, if you're looking at this on Desmos, well, I guess we're okay here. It gives you this much information. We got the foci and the vertices. So, all right, I've got a little bit more for you on the handout. But first things first, given that information, which way should I write my equation? Should it be in the form of 1 or 2? Which way looks more promising for this graph? Let's take a look back here. 1 or 2? Well, does it have to open around the x-axis or the y-axis? Opens around the y-axis, which is going to make the y squared term, the positive one, has to be of this form. So thank you, Kennedy. So let's see what we can do in terms of writing some of this equation. So Kennedy started us off. It's going to be of the form y squared over a squared minus x squared over b squared equals 1. And we know some of these things to begin with. This distance right here, for instance, tells me what a is. Now you got to pay attention to the scale here. The scale is not 1 for each tick mark. It's 2 for each tick mark. Notice that you got a 10 up here. So 2, 4, 6. A is 6. So, okay. So that becomes y squared over 6 squared minus x squared over b squared equals 1. And now we have to figure out what b is. But it's going to be kind of the same thing we did with the last one. It's just that the numbers aren't going to work out quite so pleasant. Assuming that that point is halfway between the 8 and the 10, that makes that c equals 9. And so we'll solve for c in the form of c squared equals a squared plus b squared, or 9 squared equals 6 squared plus b squared. Sorry, I went off the screen there. So that's going to give me 81 minus 36 is going to be 45 equals b squared. Square root of 45 equals b. Now I believe that you'll have two choices as to how you write that on WebAssign. You can either write it as this, y squared over 6 squared minus x squared over square root of 45 squared equals 1. Or you could just write that as 45. You don't have to write it as square root of 45 squared. I'm pretty sure that's the way WebAssign is going to roll. Now, let's draw some other stuff in here. I put points here where your rectangle has its vertices. That way it's a little bit easier for you to draw, because it's kind of hard to estimate the square root of 45. So, there. And finally here. So that's your rectangle. We need to draw its diagonals. So let's do that. Let me put those in here. And let's see, I want to use a different color. We'll do blue. The diagonals should go directly through the center of your rectangle. If they don't, then, or say center of your hyperbola. If they don't, check and see if you made a mistake somehow in drawing your rectangle. Last but not least, these open up and down and around each focus. Make sure that they touch the vertex. A lot of times people want to draw them to the center and do other crazy things. Should look like that right there. And let's do the tops as well. Beautiful. Now when I grade your exams, typically speaking, I'll give you a point for recognizing it's a hyperbola versus an ellipse or something like that. Another point for which way it opens. The rectangle is worth at least 2 points. And then, let's see, the asymptotes. Be careful how you abbreviate asymptotes. And then finally, the rest of the graph, how well you draw your hyperbola is another 1 or 2. So that's how it breaks down. There's a lot of little things. I'll give you as much partial credit or full credit as I can. But try and get all the little things, and you'll make us both happy. All right. One last one here. Example C. So let me shut off our other graph and turn on this new one. So, oh, by the way, here's the rest of the graph. Looking okay there. let's shut this off. And here's the information that's given. So in this case, all that's given is the vertices and the asymptotes. So not a lot's given, but we've got enough. So let's take a look back here and see. Let's see. There we go. You know what? Let's see. There is one last thing I want to do with the previous one, but I'll go back to that in a little bit. We know that this has to open left and right, so it's going to be of the form x squared over 1 squared minus y squared over b squared equals 1. And I didn't realize I hadn't clicked that. So x squared over 1 squared minus y squared over b squared. I get that 1 because this distance between the center and my vertice, that's a. A equals 1. Okay, now there's a couple ways you can figure out what b is, but basically the slope of this line is going to help us figure out what b is. The asymptotes have to be of the form y equals plus or minus b over a times x. So in our case, that has to be plus or minus, let's just go with the plus for the moment. Not 3. It's going to be b over 1 equals the slope here, which is 3. So I get b over 1 equals 3 because a is 3. So that means b equals 3. So that's one way to get b. Now there's another way you can get b as well. Remember, when you draw this rectangle, you're going up a height of b. So how are we going to draw that rectangle? Well, you can just draw a line, a vertical line, through this vertice, and it'll strike this asymptote at a height of b. So here, like that, and again through here. So the height here, or the value of b, is really just going to be right here. B equals 3. That's another way to get the value for b. All right, last but not least, let's figure out the foci and determine the, well, we've already got the equation of the asymptotes, so we should be pretty good there. But let's determine the foci. So our equation is x squared over 1 squared minus y squared over 3 squared equals 1. So c squared is going to equal 3 squared plus 1 squared, which is 10. C will be the square root of 10. That's going to be a little bit over 3, 3.16 maybe. So about here and here. Negative square root of 10 and 0, and square root of 10 and 0. That's going to be your foci. Ooh, there's one thing I'm missing here. One real big thing I'm missing. That is the graph. And I don't mean to make you dizzy here. Sorry about that. Perfect. So, there's your graph. Again, this should go through the vertices, not the center. It should get close to, but not quite touch, the asymptotes. If it touches a little bit, I'm not going to go crazy on you or anything like that. There was one last thing I wanted to do on example B. Any thoughts on example C before I move back? I would like to determine the equations of the asymptotes. And I'll remind you a trick that I mentioned in my video and we'll use again in the next section. And that is, if you want to find the equations of the asymptotes, then it's like solving for y when you put in a 0 here for 1. It's not a formal trick that I've seen people use, but it is a nice informal trick, and it does work. So let's see if we can't make it work for ourselves. So I'll do that over here. Y squared over 6 squared minus x squared over square root of 45 squared equals 0. And what I'll do first is I'll move this term all the way to the right-hand side. So y squared over 36 equals x squared over 45, or y squared equals 36 times x squared over 45. We could probably simplify this a little bit. Let's see. 9 goes into each of those, right? So that would be y equals 4 over 5 times x squared. And when I take the square root on both sides, I end up with plus or minus 2 over the square root of 5 times x. That's going to be the equations of your asymptotes. So if you actually look back at your graph and wanted to find those asymptotes or plot them, there you go. That would be that. So we started this out. This is just kind of a Jeff Parent, workaround. It's a quick way to figure out the asymptotes if you put a 0 there for instead of the 1, and then solve for y. The nice thing is that that trick works in section 11.4 where it gets a little bit messier. Okay, go get them.